welcome back to Teacher Gimble's channel. Today we're going to be going over illustrative math, Algebra 2, Unit 1, Lesson 3 practice. If you like this video, make sure to like and subscribe so you can start seeing more like this. If you have any questions, put them in the comments and I'll get back to you with some answers pretty shortly. Let's get started. Problem 1. Here are the first two terms of some arithmetic sequences. I never know if it's arithmetic or arithmetic. I think it's arithmetic. Sequences. Now, an arithmetic sequence means that the sequence is going to change by a constant number. So we have to identify the constant number it changes by. What are the next three terms of each sequence? So how do we get from -2 to 4? I think we added 6. So if we added 6 to get the next term, we're going to add 6 to the term before. 4 plus 6 is going to be 10. We're going to add 6 again, and we're going to add 6 one more time. And that got our next three terms. From 11 to 111, well, in that case, we added 100. So because it's an arithmetic sequence, it changes by the 100 every single time. So the next one is going to be 211, 311, 411. What about this one? From 5 to 7.5, we changed by 2.5. So we added 2.5. We're going to add another 2.5, which gets us to 10, to 12.5, to 15.5. If you have a hard time with decimals, I always like thinking of it as money. From $5 to $7.50 to $7.50, that's $2.50 that you added. So $7.50 plus $2.50 is $10. Plus another $2.50 is $12.50. So anything with 50 cents, I always kind of think about it in terms of money in my brain because then it's easier to process and do the mental math quickly. Now from 5 to -4, we subtracted 9. In arithmetic sequences, they change by a constant amount, so adding and subtracting are allowed. We could also say we added -9 if it makes it easier for you to think about this all in terms of addition. Either way are okay. They're just two different ways of writing the same thing. So 5 plus -9 is -4, plus -9 is -13, plus -9 is -22, plus -9 is -31. And we're done. Pause the video if you need a second to go over this. Otherwise, we are moving on to the next question. For each sequence, decide whether it could be arithmetic, geometric, or neither. So arithmetic, we're going to add a constant. Geometric, we are going to change by the same ratio. The easiest way I like to think about it is that each term is multiplied by the same number over and over again. Neither means we're not arithmetic and we're not geometric. So let's think about it. 200 to 40 to 8. I immediately see that we can't be subtracting the same constant because 200 to 40 would be -160, and we don't -160 to get to 8. So we could say 200 divided by what gets me 40? I do believe it's 5. So 200 divided by 5 gets me 40, and then 40 divided by 5 gets me 8. So because there is a constant term that we divide by or multiply by, then we are going to say that it is a geometric sequence. So geo. 2 to 4 to 16. Well, 2 times 2 is 4, times 2 is 8. That doesn't get us to 16. What about multiplying by 4? Well, 2 times 4, that doesn't work. What if we add 2? 2 plus 2 is 4. 4 plus 2, also not 16. I'm going to put none. It's not geometric, and it's not arithmetic. 10 to 20 is either 10 times 2, which does not work, because 20 times 2 is not 30, or 10 plus 10. 10 plus 10 is 20, plus 10 is 30. This is arithmetic. Arith. 10 to 20 to 4. Well, I immediately see it's not arithmetic, so let's check if it's geometric. To go from 100 to 20 to 4, to go from 100 to 20, I would divide 100 by 5. To go from 120 to 4, I would divide 20 by 5. So I'm going to say this is geometric. 6 to 12 to 18. Well, 6 plus 6 is 12, plus 6 is 18, plus 6, I think that sounds like it's arithmetic. Let's double check if it's geometric. 6 to 12 would be 6 times 2. And then 12 times 2 would be 24. So it can't be geometric. So we're going to call it arithmetic. All right, we wrote it all the way out this time. Let's go on to the next question. Complete each arithmetic sequence with its missing terms, then state the rate of change for each sequence. All right, we have to find our missing terms. We see it's arithmetic, so we know we're always going to be adding or subtracting a constant number. So that helps us with this. So 3 to negative 2 would be add 1. So to add 1, that's going to give me negative 1. To add another one, that gets me 0. And to go here, it gets me 1. So a rate of change is equal to 1. Here, 13 to 25 is added to 12. I added 12 to get from 13 to 25. So to go for the term below, I'm going to subtract 12 from 13, which gets me 1. This will be 37, and this will be 49. Rate of change is equal to 12. Let's look at this one. From 1, we went to 25. So from $1, we went down to 25 cents, which I lost 75 cents. If I lost another 75 cents, I would end up at negative 50 cents. I lose another 75, I'm at negative 125. I lose a final 0.75 cents, or 75 cents implies 0.75. I just think about it in terms of cents because that is easier for me to process. So negative 0.75. And it's negative because I am subtracting. Okay, this one's a little different. From 92, somehow we got down to 80. So the distance we traveled from 92 to 80 is from 18. No, it's 12. I'm sorry. This distance from here to here is 12 because I subtract the 2. I moved down 12 numbers in 3 separate increments that are the same, which means I think I subtracted 4 each time. So let's see if this is correct. If I minus 4 from 92, I would get myself 88. If I minus 4 again, I would get myself 84. And if I minus 4 one more time, I'll get myself to 80. I think I made a mistake because that's not correct, which is why we always need to check our answers. So from 92 down to minus 4, that's going to be 88. That is correct. Minus 4 is going to be 84. Minus 4 is going to be 80. Let's divide this by 4 instead of 3 because we're going from 92 down to 80 and we're including this value here. So if we divide 12 by 4, that's going to be subtracting increments of 3. 92 minus 3 gets us to 89, minus 3 gets us to 86, minus 3 gets us to 83, minus 3 gets us to 80. All right, that worked. So sometimes our initial mathematical reasoning is not going to be correct, and that's okay. In this case, I was like, the distance between 92 and 80 is 12, so we have to go in 12 increments. But because I was including 80 in that distance, I actually had to include that in the number of increments from 92 to 80. So be a little bit careful. Always check your answers, and mistakes are okay. That's how we continue to learn. Next question, problem 4. A sequence starts with the terms 1 and 10. So we have 1 and 10. Find the next 2 terms if it's arithmetic. Well, if it's arithmetic, that means we're adding or subtracting something constant. And 1 to 10, that means we added 9. So this would be 19. And plus another 9 would be 28. If it's geometric, from 1 to 10 means we multiplied by 10, which would make this in 100 and this in 1,000. Find the next possible 2 terms if it's neither arithmetic or geometric. Well, I'm just going to do plus 9 times 100. So, well, no, that's not going to work because 1 to 10, it has to follow a rule. So let's say we added 2 and we added 1, then multiply by 5. And the reason that rule works is because 1 plus 1 is 2 times 5 is 10. So the next term would be plus 1, which is 11, times 5, which is 55, plus 1, which is 56, and 56 times 5 is 280. So that would be a sequence that is neither geometric or arithmetic. Let's move on to the next one. Problem 5. Complete each geometric sequence with the missing terms. Then find the growth factor for each. So they told me it's geometric, which is helpful for me because I know there's always going to be a constant rate of multiplication, and multiplication and divisions are partners. So we know it's either multiplication or division if you want to think of it as division. And let's get started. From 5 to 25, we multiplied by 5. So 25 times 5 is 125. That's going to go there. And if we're going backwards, we're going to divide by our rate of change, and that's going to be 1. Negative 1 to something to negative 36 to 216. I believe that we are multiplying by negative 6. So negative 1 times negative 6 is positive 6, times negative 6 is going to be negative 36, times negative 6 is going to be 216, times negative 6 is going to be negative 1296. All right, here we did 10 to 5, so that halved it. So I multiplied by a half. So a half of 5 is 2.5. Multiplied by that a half again is going to be 1.25. And when you multiply that by a half again, that's where we're going to get 6.25. All right, let's move on to the next one. Now, if you're having trouble with what I'm doing here, make sure to pull out your handy dandy calculator in order to double check some of these answers. I'm doing this mostly with mental math and some calculator on the side. 36 to 108. Now, I'm not immediately sure what my scale factor here is, so I'm just going to divide 108 by 36 to figure out what I multiplied by. I'm not paying attention to the sign quite yet because I want to figure out the scale factor. So I find out that 108 divided by 36 is 3. And that tells me 36 times negative 3 got me 108. So 108 times negative 3 is going to get me my next term in the sequence. 108 times negative 3 is 324. Dividing by 3 is going to help me go backwards. So 36 divided by 3 is 12. Divided by 3 a second time is 4. And it's divided by negative 3, which is going to make this a negative. Divided by negative 3 again makes that a positive term. So be careful with your negative and positive terms. But if you've been noticing in our geometric sequence, when you have the scale factor or rate of change that's a negative number, our values flip between positive and negative. Now, 12 to 18 to 27. I have a feeling here that we are our scale factor is a fraction. So I'm pretty sure it's 1.5. So in my handy dandy calculator, I'm going to multiply 12 times 1.5 to see if I get the correct answer. So 12 times 1.5 is 18, which means 1.5 is a scale factor. That makes sense in this case. So I'm going to say 27 times 1.5, and that's going to get me my next answer. Now, some of this you could do as mental math, and just to tell you how I figured out 1.5, I realized that 18 is not double 12, but it is bigger than 12. So it has to be more than 1 times 12, but not 2 times 12. And half of 12 is 6. So 1.5 times 12 would be 12 plus a half, and half of 12 is 6, and 12 plus 6 is 18. And that's how I got it. Now, 1.5 less than 12, or I would just, in this case, take 12 and divide it by 1.5. There are other ways to do the mental math there, but it would take a little bit of time. So I'm not going to do this. Now, some of these are always guess and check. When you're looking for scale factors or rates of change, you might have to do a little bit of guessing and checking, but the nice thing is, there's a very easy way to check to make sure that your computations are correct. Let's go on to question number 6. The first term of the sequence is 4. Choose a growth factor and list the next 3 terms of a geometric sequence. So I've been using the word scale factor, they're using the word growth factor. It's the same thing. I'm going to choose 3 as my growth factor. So 4 times 3 will give me my next term, which is 12, times 3 again, which is 36, times 3 again, which will get me 108. And I got my next 3 terms. Let's do it again. Choose a different growth factor and list the next 3 terms of a geometric sequence. I'm going to say 1/2 as my growth factor. So 1/2 times 4 is 2, times 1/2 is 1, times 1/2 is 2, times 1/2 is 1/4, times 1/2 is 1/8, and you can continue it. I did more than 3 terms. There are an infinite number of growth factors you can choose from. Go ahead and choose some and try it on your own. Our last problem, problem number 7.